All right, today we are going to be simplifying expressions. So what does that mean? So to simplify, would be to make more simple, right? So we want to have less terms. So I just threw a bunch of different vocabulary at you. So each one of these little pieces, like 3x and 2x, those are considered terms. So every time you see a plus sign or a minus sign that separates these things, they're called terms, and we want to have less of them. We want something that's simpler, but it still needs to represent the same thing. So 3x plus 2x, if I told you what x was, you could plug it in, and you could get an answer. Now we're going to simplify this, so it's no longer going to say 3x plus 2x, but it's going to be equal to it. So if we put in a number for x, it's still going to have the same value. Okay, an expression is just any of these number sentences that don't have an equal sign. Once it has an equal sign, now it's an equation. Okay, so for today, we're going to be combining like terms. So a term is just either a number by itself or a variable by itself, or when a number and a variable are attached. That's a term. And we're going to combine like terms. So like terms have the same variable or no variable. So a number by itself can be combined with another number that's by itself without a variable. Alright, so I'm going to use a couple different colored pens here to demonstrate this. So when I look at number 11, 3x plus 2x, I see two terms, 3x and 2x, and they are considered like terms because they both have an x as the variable. Okay, two terms. And they're alike because they both have x as the variable. So I can combine these because they are alike. So if one was an x and one was some other letter like a y or a z or anything else, I would not be able to combine them and I wouldn't be able to simplify. But I can simplify because they're both x's. So I can basically put them together and just make them one term. So if I combine a 3x and a 2x, all I need to do is combine the coefficients. There's another vocabulary word. Coefficients. That's the number attached or being multiplied with the variable. So in this case, the coefficients are 3 and 2. And since they are like terms, they have the same variable of x, I can combine the coefficients and just make this one term. So a 3 and a 2 is a 5x. Now, for the sake of this one, let me show you why this works. So let's just pretend that x is, let's pick something easy, 4. So if x is 4 and I wanted to plug it into this one, I changed x to 4. So instead of 3x plus 2x, I have 3 times 4 and 2 times 4. What would that equal? Well, 3 times 4 is 12, and 2 times 4 is 8. And if I add it together, that's 20. So what if I plugged 4 into this? 5 times 4 equals 20. So these are equivalent. They are equal. They mean the same thing. But this is much simpler, especially when I go start trying to plug numbers in. It's much more simple to do 5 times 4 than to do all this multiplication and addition up here. You still get the same answer. So we're just making this simpler, easier to work with. So if I slide over to number 12, I have two terms, okay, and they are like because they both have the same variable of b, which means I can combine those like terms, and to do so, I combine the coefficients. Now, this is a minus. This is like a 3 minus a 2. So a 3 minus 2 is a 1. So it's a 1b. But you will never see this. If you look on this paper, there are no 1x's or 1b's. But there are letters that are by themselves. Okay, there's really a 1 in front of it. We just don't write it. So instead of 1b, we are just going to put B. And that's your final answer. So one more time, let's plug into these and see what happens. So let's again make this a 4. So if it's 3 times 4 minus 2 times 4, so rewriting this, plugging in my answer of 4, just making up a number. It can work for any number. You plug it in and it's going to be 12 minus 8. So this equals 4. Well, if I just have this simpler expression, term of b, and b just equals 4, boom. How much easier is that? Instead of doing all this, b is just 4. All right, so these are equivalent. They get me the same answer, but one is simplified. So let's look at 13. 2 terms. And they are similar, right? They are like terms because they both have an x, so I can combine this. Now this is a negative 8 and a minus 10. If you wanted to, you could change this to a plus negative 10. So the 2 terms that I'm combining are a negative 8 and a negative 10. That's a negative 18x. Sliding over to 14. 2 terms. They are alike. They both have a variable of x. So I can combine these. Coefficients are 10, and this is negative 1. Okay, so there's really a 1 there. This is a negative 1. So when I put this together, negative 1 and 10, that gives me a total of 9. And again, I could plug any number I want into this, and they're going to give me the same answer. So this is just a simpler version. All right, let's go over to 15 now. Now we start throwing in a little more. So I've got, count them, 1, 2, 3 terms, and they're not all alike, so I can't combine all of them. So this will not simplify down to just one term. My answer is not going to be one term like the first 4 were. So I'm still going to have plus something. So the only ones that are alike are these 2, because they have a variable of n. This 12 is not like those 2 terms. Doesn't have the same variable. So I can only combine these 2 like terms. So an 8n and a 3n make 11n. And then what do you do with the 12? Well, you can't combine it with this because it doesn't have an n. If it had an n, then sure, combine it. But it doesn't. Okay, so that plus 12 is just by itself, basically. You're going to tack it on here. You're going to write another expression that is simpler. It has 2 terms compared to the 3 terms that we started with. And again, these are equal to each other. If I plugged a number in, they're going to come out equal to each other. So if I plugged in 2 and 2, but I plugged in 2 here, this is going to give me the same answer as this. All right? So notice, they're not always going to simplify down to one term like the first 4. All right? If we have things that are not alike, you're going to have more than one term in your answer. So this is an expression. There's no equal sign. It's a number sentence. It's an algebraic expression because there's a variable. Okay, an algebraic expression because there's a variable. And it has 2 terms. And that's my final answer. That's as far as I can simplify that. I can't simplify it anymore. So come over to 16. 3 terms. 2 of them are like terms. The 3 and the 5. Because they don't have variables at all. 7r, it's kind of by itself. It doesn't have anything that's like it. So the 7r is just going to stay. And you can now combine these 2 that are alike. So a 3 and a 5 is a 8. And it's positive plus 8. Now notice how I wrote these first 2. Maybe you didn't realize I was doing it on purpose. But when I have more than one term in my answer, I've always put the n and the r up front. And that wasn't on accident, that's on purpose. So let's make note of that. So when there is more than one term, the variable goes first. Okay, that's one of those things that's just proper form. It's still equal to, if you put 12 plus 11 in, or you put 8 plus 7r, that's not wrong, it's still equal. But proper form is going to have those variables up front. All right, look at 17. I've now got 1, 2, 3, 4 terms. And I've got lots of different things that are alike. I've got a 7x and a 10x. Those are alike. I've also got a 3 and a 1. And those are alike because they don't have a variable. So now I've got different colors here, so it's easy for me to see these go together and my red ones go together. But if you're just working in pencil, you may want to draw shapes or something to distinguish between these different terms. So here's what I want you to do. I want you to put a box around the 3 and the 1, and I want you to put circles around the two terms that have the variable x. Now, when I look at this, I can only combine these, and I can only combine these. So the 7x and the 10x is a 17x, and the 3 and the 1 is a 4, a positive or a plus 4. So it had 4 terms, and I simplified down to 2 terms. Now, if you notice, when I boxed these in, I included the plus that was in front of it. I did that on purpose. That wasn't an accident. So that's important. That tells you whether this is like a positive or a negative, because like we did up here, if there's a minus in front of it, you can always say plus a negative. So a minus sign is going to act like a negative sign. And so it's important to consider what's in front of the number. Now these were all positive, so it didn't make a difference. But as we start moving towards these ones with subtraction, it's important to realize that that goes with the number. So 18, 3 terms. Let's put boxes around our k's. So notice it doesn't matter what you choose to put around them, but put something that's similar. And let's put a circle around our numbers that don't have anything. So I can only combine the boxes, the k's. So a 5k and an 11k is 16k. And the plus 7 doesn't have anything to combine with, so I'm just going to tack it on the end. Again, more than one term, put the variable up front. So 19. Practice putting your boxes around the v and the other v, putting circles around the plus 5 and the minus 9. That's important. Let's start with the v's though. So when we combine the v's, we need to know this is a 1v. It's not written, but there's a 1 and a 1. The coefficients are 1 and 1. So if I combine them, 1 plus 1 is a 2v. All right. Now I have to combine this 5 and this negative 9. I know that's subtraction, but we've talked about you can change a minus 9 to plus negative 9. So this is really a negative 9. If it helps you to change it like I just did, then do it. But once you realize that a minus is a negative, you don't have to make that change. But you do need to consider it a negative. So this is not a 5 and a 9. This is a 5 and a negative 9. So when I combine those two, I get a negative 4. So technically you could write plus negative 4 if you wanted to. But this is not a simplified expression, because we never want to write plus a negative if we don't have to when we're simplifying. We want the least amount possible. That's the whole point. Simple. Least amount possible. So adding negative 4 is the same as subtracting 4. They mean the same thing, and this is the version that I want. Okay, so you can go straight to this. When you realize when you're going to put these together and you're going to get negative 4, you can go straight to minus 4. Perfectly fine. Okay, number 20. Box in your k's, include what's in front of it, so that minus is with that k. And your numbers, I'm going to put in circles, is a plus 7 and a minus or a negative 2. So here we go. 5k and a minus k, or a negative 1k. So think of it as 5 minus 1 or 5 plus negative 1. Either way, that's giving me 4k. And then combine these two together, plus 7 minus 2. It's a 7 and a negative 2. Together they make a positive 5. So since it's positive, I'm going to put plus. If it was negative, I'd put minus 5. So the 7 and the minus 2 give me a 5. Last two, let's run through them quick. My variables here are negative 9 and 6, and my whole numbers are a 1 and a 2. So negative 9 and 6 is negative 3p, and 1 plus 2 is positive 3, so I'm going to put plus 3. And then over here, negative 3r and r, and 13 and 13. So this is a positive 1, so negative 3 and positive 1, that's negative 2. And 13 is a positive 26.